In this video, I'll be looking at the construction details in FEMA P-1100. I've been a seismic retrofit contractor for the past 25 years, the largest retrofit company in the San Francisco Bay Area. And I've looked at a lot of houses. I would probably say 4,000 conservative basis. So I've been under a whole lot of houses. And one of the things I noticed here is in a lot of these framing configurations, I've never actually seen them, or I've seen them so seldom I can barely ever remember seeing them. So the first thing I will say when I'm doing my analysis, I will say whether I've seen them or not. And then I will assume that they are found in Southern California, and we'll address them from that perspective. I personally believe there's no point in putting construction details for configurations that barely exist, or construction configurations that only apply to a certain geographic area, because we want to reach as wide an audience as possible. I noticed a few things right off about this drawing that aren't quite accurate. The existing studs are actually 2x4, and that's a full 2x4, and the blocks are new. They're 3.5 inches. Now all the old material until probably 1955, that's 70 years ago, they had full dimension. So when you bought a 2x4, it truly was 2 inches by 4 inches. Now later on, to save money, a 2x4 became 1.5 inches by 3.5, but all the old houses that are retrofitted, they are full dimension, and that should always be kept in mind, because a 2x6 is actually 6 inches wide. A 2x8 is actually 8 inches wide. So these construction details should reflect the fact that the existing conditions are full dimension like that. This is fairly minor, but it should probably be addressed anyway. This distance marker here says that the distance from the center of the bolt to the edge of this piece of wood right here should be 1.5 to 2 inches. Now it's calling this block a foundation sill. It's saying that this right here is the edge of the foundation sill. This is actually the block. What this should really say is the edge of the block. This is the actual foundation sill. This is the sill. And this is a block. And it's important for these construction details to name things accurately. It really confuses contractors if they see foundation sill over here and they see the exact same thing called a block over there. So consistency is very important. Finally, I'd like to make a few other comments. First thing I want to point out is that this will always be a 2x4. Because to go a full 4 inches like this, you actually have to take a 2x6, which is 5.5 inches wide, and cut it down to 4 inches. So that's just never going to happen. So there's never any point to have a detail that has anything other than a 2x4. Plus, overall, they're cheaper than 2x6s. If you're dragging stuff under a house, you're going to want to have 2x4s and not 2x6s. So there are lots of reasons why you only see 2x4s. The other thing I want to point out is that this detail has references to reinforcing steel in 2 places. So right here it says that may be shifted if existing reinforcing conflicts with placing new foundation sill anchor bolts. And I doubt anyone on this committee has ever tried to drill through rebar. I mean, I don't know that for sure. But when you hit rebar, you're automatically going to want to move it. There's no way to get through it with a concrete bit. Cutting rebar is extremely labor intensive. It's a special bit you have to have, and they cost like $50. You can use it like 3 times. You have to throw it away. So contractors are going to move it no matter what. And then this last thing says, do not drill through any existing reinforcing. Now, in some cases, you have to drill through the reinforcing. So, for example, if you're putting in a tie down and you need to go 15 inches, deep, or as deep as you can get, you have to cut the upper piece of rebar. Otherwise, you're never going to get it. You're never going to get your all thread down the hole. So that is a time that you do have to cut the rebar, and like I said, there's a special rebar cutter for that. And finally, the upper piece of rebar doesn't really matter. It's the lower one that does all the work, and beyond that, all the tests of all the bolts and the URFPs, all this hardware that goes into concrete has all been tested in unreinforced concrete. So there's no reason to go beyond what's already tested And so I personally believe that any mention of reinforcing steel should be simply be removed, except to maybe remind the contractor, you know what, if you hit some reinforcing steel, don't worry about it. Just move the bolt over, just move the bolt over a little bit and you'll be fine. This detail has quite a few problems, but one of them is so glaring that I think it will discount the entire detail for consideration. And that is that it uses the connector type B. And it uses it in such a way that it is contrary to the manufacturer's instructions. So I think that alone should discount this detail altogether. This is a framing configuration I never see, so I will assume it is found in Southern California. There are a couple of things I would like to look at in this detail. The first one being the screw that attaches this 3x to this existing joist. In this detail, you can see that this is a 3x member, meaning that this is 2.5 inches thick. And then we have this 4-inch lag screw that goes through the 2.5-inch member and then into the floor joist 1.5 inches. So we have 1.5 inches of penetration. Now if we come over here and we look at the geometry that Simpson Strong-Tie says we should be using, where basically this is the 3x member, and then this is the slag screw, and then this would be what we call a joist. So you just kind of have to turn this whole thing upside down to make it look like the construction detail we are dealing with. But the main thing is it does have a 2-inch minimum penetration. And in the detail shown in P-1100, it's only 1.5 inches. Here are two other things I'd like to point out. In these notes, it says that minimum end distance is 3 inches and minimum edge distance is 5/8 of an inch. Now, getting that 5/8 of an inch in a practical point of view is extremely difficult. Very, very difficult for anyone with any type of tool to go through 2.5 inches of lumber, go straight into the center of a joist, which is what that is if you have 5/8 tolerance on either side. So 5/8 tolerance means they're actually allowing you to have 3/4, but to take 1/8 of an inch off that is now your 5/8 tolerance. The probability of getting a screw gun, putting it right through the center of this 2.5 inch member, straight into the center of the joist is basically impossible to do. No one's going to be able to do it. So in my opinion, there's no reason to put something in a detail that no one is going to be able to do anyway. There is a way to do it, but it's extremely complicated. And I do have a video that you can watch that goes into exactly how it's done. The other thing I'd like to point out is that there really is no reason to use 3x. 3x simply costs more money. It's heavier to drag under a house. And then this angle steel right here connecting this to this is completely unnecessary. The way this would normally be done is you would nail straight through the ledger into these framing member right here, however you want, 2 inches on center, 3 inches on center, whatever, and just forget this whole assembly right here. From a practical point of view, nailing this up, and then attaching this, and then trying to make sure they line up perfectly, and then put in this piece of steel. That's just such a huge hassle, man. You can just go ahead and put some nails through it and be done with it. So the way this is normally done is you put nails through here, and then you put nails through here, and you don't have to worry about any of that stuff I just talked about. After looking at this detail, I thought about why it was that the designer made it, so complicated. So as you'll recall, what the designer recommended was that there be a piece of steel that connected the ledger up here to this member right here. So there was a piece of steel that went like that, an L90 or something. So what this engineer, I'm sure, believed is that first you would nail this up, and so this is all set in place. Then you would take this, and then you would bolt it here. And now you had to connect the two together, so you would take a piece of steel, right angle piece of steel, and you connect it right here. Well, the way the contractors do it, that do this all the time, is all they do is they nail this to this. So now this is just one member right here. They drag the whole thing under the house. They push it up against the joist, and then they put some nails into the joist right there with nails rather than screws. So it's actually a very simple operation, but you just have to have some experience and know how to do it. This detail has a few problems. One of them being we never see a joist right here butted up against the concrete, and then another joist right here, a ledger that you can put in there and then attach the two. Number one, this is always a full 2 inches. And this is nominal lumber, so you have a 1/2 inch offset between these two. So it's actually impossible to put in this type of anchor when there's a 1/2 inch offset. The other thing is this is Douglas fir, and then this is Douglas fir with flashing behind it because it will decay. So we can assume that this joist, which is Douglas fir, has probably been there 75 years at least. And so we can assume that this piece of wood behind the concrete is all rotted out. So this is probably not the best piece of wood to even attach anything to anyway. And the other thing is you can actually just take a right angle hammer drill and you can just bolt it straight into the concrete like that, and then just forget this whole mess right here. I can't remember when I saw this framing configuration last, but there's a foggy memory that I did see it once or twice. And the way we would address it, again, would be to bolt it from the side with a right angle hammer drill. But if for some reason you wanted to keep this in the detail set in P-1100, the way I would show it would be to show a piece of 1/2 inch pressure treated plywood right here. And that way, this 1/2 inch pressure treated plywood plus the nominal 2x would match the thickness of this full 2x right here. So that would be the proper way to do it. Now, whether it's rotted or not, where the existing joist touches the concrete, that's anybody's guess. So anyway, I hope this helps the committee understand what this detail is all about. I really don't see the point of this connector right here. So this is a 2x6, and at the most it's going to be 2 inches, and at the least it's going to be 1.5 inches. So if we look over here at the type A connector, we see that the distance from the top of the connector to anywhere at the bottom is that it's only 1.5 inches. So even if you put it at a radical angle like that, it's still 1.5 inches. That's the way it's designed. So what that means is you can get rid of this whole assembly, the side bolt mudsill, mudsill is what we call them. Get rid of this piece of hardware, and then just put in your simple type A connector, just like all the rest of them. And then you can get rid of this piece of hardware right here, put in a simple L90, and you basically just do your standard retrofit just like you do everywhere else. We avoid putting a new ledger on the side of the foundation. These are very labor intensive, so depending on the size, it takes 2 people to hold it up. Let's say it's 12 feet long. You got to have one person on one side, the other person on the other side, and then a third person in the middle to drive the bolts through the center with a rotary hammer. So if you can just use your standard type A connector hardware, it is so much easier and saves so much money. And I really can't see any point for this detail. This is a detail that I am sure I've never seen, so I'm going to assume these are common in Southern California. First thing I'd like to point out is this subfloor right here is sitting directly on top of the mudsill. That's what's unusual about this configuration. And then there's the joists that are supporting it. Now, I would not expect this joist that's touching the concrete right here to be in any good condition. It's probably rotted out right here. And when I went to the Southern California to talk to the building departments there in 1994 after the Northridge earthquake, I was actually given the original guideline for seismic retrofit of existing buildings, and it had a detail in it that showed rotten wood where it had been touching concrete. The sills in Southern California are all made out of Douglas fir, so it looks like the engineers down there saw this fairly commonly, and so they addressed it in that particular document. It's not there anymore, but it used to be. Now, the other thing I'd like to point out is this piece of hardware right here. That's a type B connector. Now, type B connectors always have a shim right here. The probability of the sill and the concrete lining up perfectly right here, it just flat out never happens. So there should be something designed here that doesn't require the type B connector. We do see subfloors that are nailed to the mud sill sometimes. So here, this is the subfloor. This is the mud sill, and then these are often nailed right into the mud sill like that. Now, the way we retrofit these is we simply put a type A connector here. Sometimes there's concrete in the way, like you see here. We just take a hammer and we bash out that concrete, put in the type A connector, and we're all done. Now, if you come over here, we also see a situation where we have the floor framing, the subfloor, nailed directly to the top of the cripple wall. We see that sometimes. Now, we usually find this in houses that are built in the late 50s, early 60s, and pretty much it just seems to have been a style for just a couple of years. And one thing that's unique about these houses is they don't have floor joists. You can see there's no joists here, and there are no joists here. What they have instead is a girder system. So you'll see a girder every 4 feet, and then the tongue and groove flooring that you see here is nailed directly to that. The detail on the left is FEMA P-1100's method of addressing balloon framing. We see balloon framing from the 1890s to about 1915, primarily in San Francisco, but we do see it everywhere in the old houses. So it's normally in the old houses, so we don't do a whole lot of retrofits with balloon framing, but we do see it sometimes, and it certainly is a detail that needs to be part of P-1100. Now, these old houses, they were made out of 2x4s and 2x6s, and sometimes 2x8s. The walls were made out of that lumber, and a 2x4 truly was a 2x4. It was 2 inches by 4 inches. A 2x6 was 2 inches by 6 inches. They didn't have nominal lumber back then. What you bought, what you said you were getting is exactly what you're getting. So when you see a detail like this where it says put in new 2x blocking, that means you'd be using a 3.5 inch wide block, and the wall would be 4 inches, so that would leave a 1/2 inch gap there, and really doesn't perform as a fire block at all. So in order for this to work, you'd actually have to take a 2x6, which is 5.5 inches, cut off 1.5 inches, and then put the block in there. And another thing is, if you look at a house and it's 50 feet long, and you got to do this in every wall cavity, the contractor is going to go broke, and it's simply never going to happen. So I would say that component of this detail should simply be eliminated. I'd like to show you that this detail also has a lot of moving parts. So we have this 3x block right here. Then we have this ledger right here, and then we have another block right here. So this 3x here is only attached to this block with 2 3-inch screws. So with 2 3-inch screws, that's just, I believe that's just not enough screws, because if the plywood is at, say, 2 or 3 inches on center, the screw capacity isn't going to be, what it needs to be. The capacities just aren't going to match. And then you put in this block right here, and it doesn't say actually how the block is supposed to be held in place. We're going to assume that those are toenails. And then you have this connector right here to connect the two, and that is your complete load path. Now, another way to do this, which is much simpler, is you take a 2x4 and you back staple a piece of plywood. So here's your plywood, and then we're back stapling it like here to minimize any splitting. Then we take a piece of 3/4 inch plywood, we nail it to our 2x4 right here. It sits, it's in between the joists, fits real tight in between the joists, and that's it. This is FEMA P-1100's way of using the existing ledger. First they put in this block like we saw in the other details, and they nail it to the piece of plywood. This is just a lot bigger hassle to do than the detail on the right. And the thing I'd really like to point out is they're only wanting 2 screws to attach the existing ledger to the new block right here. And that really makes no sense at all. It just isn't enough capacity. This detail is exactly like the P-1100 balloon framing detail that we just saw, except here they're using a type D connector, basically the same as an L90. That's the only difference. FEMA P-1100 does not have a good retrofit strategy for those circumstances where there's a ledger nailed to the sides of the stud. So here's a stud right here. There's a whole row of them, maybe 10, 15, something like that. And then this ledger right here, it's existing, it's nailed to the stud. And this is going to be a full 2x right here. So the strategy that we use is we take this 2x4 block, we back nail it here. This is the plywood right here. And then once we get that done, all we have to do is sink some nails that way, and that's it. So this is really simple. There's only 2 connections. You got your connection here, plywood to block, and then block to ledger, and that's it. Now this one is extremely similar. Here we have the exact same situation, except here we have the piece of plywood. Then we have this 2x4, which is 1.5 inches, and because it's 1.5 inches plus this 1/2 inch, we're the exact same dimensions as this old growth 2x right here, and now they're in the same plane right here, and we can just go ahead and put a piece of plywood right there, and we're all done. So this is a very good option for dealing with balloon framing. This type of house here you find all over the San Francisco Bay Area. It's a split level house, and these are almost always balloon framed. Let me show you how they were built and why they're balloon framed. So this would be the original structure. I mean, the first thing that they built would have been the garage, and then this living area above the garage. So this whole section would be built, independently of the rest of the house. Then what they would do is they would take this lower floor, and the floor framing they would nail to the studs that are right here. So there will be a ledger that extends all the way from the front of the house to the back of the house, and that creates a balloon framing situation. So it's very important that these details for balloon framing be good ones, because we see this all the time. And the other thing I have to say I see all the time is every time I look at one that someone else has retrofitted, they always do it wrong. So these details are extremely important.